finding the area between curves. Let's have a look at these questions. So in these, you won't, in the first one, for example, you wouldn't be expected to know what these curves would look like. The red line in here, well, this line here is the curve y squared equals 3x. Again, this is not a function because there's more than one value for y given a particular value for x, but it's a curve that we can use, and I can rearrange that to give y equals the square root of 3x. And the other line, this one here, is the curve or the function x squared equals 3y, which we can rearrange for y equals x squared over 3. And if you look at the curves, we can see to get the area between the curves, it's going to be the area under the y squared equals 3x curve minus the area under the x squared equals 3y curve. So the area equals the integral of the root 3x dx minus the integral of x squared over 3 dx. The only thing we've got to do is find these limits a and b, which correspond to the intersection there and there, these points on the curve. So the first job is to find out what those points are, which gives us our limits a and b, and then we put those into the integrals and perform the integral. So how do we find the integral? Well, we've got the first curve gives us the expression as y equals root 3x. The second gives us the function y equals x squared over 3. And so when they intersect, y's are equal, so we can say that root 3x equals x squared over 3. So we have an equation that we can solve, timesing both sides, or squaring both sides. We get that 3x equals x to the 4 over 9. Dividing both sides by x, we get 3 equals x cubed over 9. And timesing both sides by 9, we get x cubed equals 27. So x is the cube root of 27, which is 3. And looking back at the function, we can see that actually another value of x here that would allow this to be true is if x equals 0. So the points of intersection are x equals 3 and x equals 0. So those are the limits that we put into our integral. So you can go back to this original integral and put in the limits and find the area under the curve. See if you can carry on and finish that off. Okay, let's have a look at the solution. So the area equals, taking the root 3 outside the integral, this is the integral between 0 and 3 of x to the half dx, minus, again taking the third outside the integral, it's not essential you do this, we taught 0 and 3 of x squared dx. So this is going to equal root 3 times x to the 3 over 2 divided by 3 over 2 between 0 and 3 minus a third x cubed over 3 between 0 and 3. Root 3, the 2/3 can, 3 over 2 can come outside, become 2/3. That's x to the 3 over 2 between 0 and 3 minus, again the 3 can come outside the square bracket, so this is 1 over 9 x cubed between 0 and 3. Obviously when we put the limits in, the 0 is going to give us 0 in both cases, and if we think about 3 is the root 3 times root 3, so this actually becomes 2 over root 3. Putting the limits in, it'll be 3 to the 3 over 2 minus 0 minus 1 over 9 3 cubed minus 0. And there you calculate, finish that off, you should get the answer